I'm going to run through a lot of material very, very quickly, and then because I want to get to a demo where I pull some poor soul. Is Ahmed here today? I'm just going to pull him if he's here. Pull some poor soul out of the audience, and we'll get to sit here and enjoy what's going on in your mind in real time. So I started this adventure about 30 years ago. So I was an educator, master's in education, and I had students that couldn't pay attention. I had a background in computer science, physics, math, and I said, I'll fix them. I'll create a program that will fix them. So I found out that NASA was using neurofeedback to train astronauts in states of hypo and hyperarousal to pay better attention. I'll enhance that. So 6 years later, working three jobs, 6 days a week. There comes play attention. So I actually, at that point, understood that ADHD was not just this simple problem of attention. It's a problem of executive function, which opens up a huge can of worms. Can we build the skills, the cognitive skills that support executive function and help with behavioral control and improve their attention? So I did all of that, and I put it into what is called a deliberate practice module. It was then tested by Tufts University School of Medicine in 3 randomized controlled studies with an N of 109. We were tested against brain games, very similar to Lumosity, and then a non-intervention, because Tufts told me that they didn't think that the neuro component was necessary. They thought it was an added expense, and that brain training is brain training is brain training. Well, they did a pilot study. Our students in the Boston schools knocked it out of the park. So we excelled in behavior control, in executive function, in attention. And some of the students got off their meds. So then that attracted bigger attention. The U.S. Department of Ed gave them $1.5 million to do a long-term study and then a follow-up study. Same thing occurred in the long-term study, except we had the control groups. So in the control groups, the brain games folks got no improvement in any of those categories. The non-intervention, no improvement. The only thing they increased in is their need for medication, an average increase of 9 milligrams to stay in school. Ours, none. As a matter of fact, most of ours were either off or didn't require any increase. So there was a significant difference in the way that we packaged this training. It's not your typical neurofeedback training, I can tell you that right now. The fact that we actually use cognitive skill games to promote executive function and then add a behavioral shaping mod package in it with the deliberate practice module made a huge difference. They went back 6 months after that final testing and then to see just basically if there was some perseverance, whether they were going to retain the skills that they had, and they did. So all of these are published in 3 medical journals and provided a lot of success. That package is now sold as Play Attention. It's distributed globally in 10 different languages. And that's how I got started. Then after this, so I effectively created the genre of neurocognitive training at that point. After that, I decided I needed to move out because the technology is so powerful that it could make a vast difference for our lives. All of us. And I'll go into that in detail. But the problem with it is that wearing headsets is problematic. You cannot get the consumer to do it. I was called in by Sony. They asked me about using a body-based application. I might be able, if we have time, to show you that, of detecting neurosignal. And I said, well, I know that you've been working with some of the headset manufacturers. Why call me in? We can't get the public to wear them. All of the tests and getting the public acceptance are just really bad. And you saw what happened to Google Glasses, which was a great idea, except it won't pass muster with the public. So that's kind of the evolution of where this all went and how this got started. I was soon after the success with Tufts and the body-based application, Time Magazine picked me up and gave me a 3-page article, and then I was invited to speak at NASA on the behalf of the Space Society in Washington, D.C., and then we created training software for nuclear operators and to help them pay better attention. And if you actually knew what was going on in nuclear facilities, you would be worried. I could talk to you about that later, but sitting with the engineers at the IAEA in Vienna and watching what is going on is incredibly alarming. So I'm happy to be training those folks. All right.
We saw The Simpsons.
You saw The Simpsons. It is not too dissimilar. There is no control except a stack of books at the back of the room. When something goes wrong, they pick up one of those big black binders, and it's got a flow chart. If this is happening, try this. If that works, go to this. If it doesn't, go to this. So it's nothing like you think as far as having... Most mistakes at nuclear facilities are human-based. They're not mechanically based. Okay, enough of that, because that's an adventure all in itself. So I think, after all of that, one of the most profound things I ever learned in all of this is that the brain is an organ of reduction, right? Everything, every starry sky, every moonlit night, every sunset, every kiss that you've ever had, everything you ever learned in school, everything is reduced. It's reduced to the random firing in the brain of these neurons. All the gentlemen before me have been just talking to you about how they're trying to control this, how they work with this, how can I be the commander of this inner universe that I do not have any connection to until I start using technology. And so that is really the basis for everything we're going to be seeing here today. The ability to master and command our inner net. All of this that we can get fundamental control of and make our lives better, safer, and healthier. We're going to move forward. There we go. All right, so there is a quiet revolution happening. People are wise to what is happening in their lives. So AARP, you don't have to read all of it, but it's interesting. So they surveyed a good number of their members and said, what's important to you as you get older? And by the way, the country, by the year 2030, 2035, not too far away, most of us will be over 65 years old. The majority of the population will. So what's interesting to them at that time? Is it wealth? You want to have wealth management, big amount of wealth? Do you want to have great health? Do you want to have a happy marriage? Do you want to be able to travel? And everybody said, no. 80% of them said, I just want to stay mentally sharp. Because what's happened to us all, right? We've seen people who are very wealthy friends of ours get Alzheimer's. And it doesn't matter how much money they had. They were dead in a very quick amount of time, or it's a miserable existence for a little while. So everybody's like, maybe the best thing for me is to stay mentally sharp, right? And that's where this quiet revolution, this is what Jeff and I think Nicole are aiming at, that people need to understand where we're all going with this and how we can actually command this universe, but this is our future. Can we actually put this all together? And that's essentially what we're working on right now. So neuromonitors can vastly benefit us, but there is a roadmap, right? Number one, wearables on the head are kind of out of the picture at this point. They just have not made it. They're not going to make it, it appears. So they have to be embedded into everyday wearables. There is a neuromonitor in this headrest that I now am in development with 7 different auto manufacturers and 3 of the tier 1s that supply the auto manufacturers I work with. We just did a drowsiness algorithm through one of the major manufacturers, or actually a couple of the major manufacturers. We tested against a thing called PerClose. PerClose is a camera that looks at how much your eyes close and tries to tell you that you're drowsy based on the eye closure. It's the industry standard. We beat PerClose by anywhere at our worst 2 minutes, at our best 10 minutes in detecting drowsiness. Additionally, we took a sleepiness scale in those studies, and the sleepiness scale, we had an 80% correlation with the Karolinska scale. PerClose had a 0% correlation. All right? So we know that these will be very, very effective, and I know it doesn't look like much, but there is an array inside that thing that actually does look at brain activity, but it's entirely discrete. That is what's going to happen if we're going to have it in everyday life. There is going to be an added expense because the public really doesn't understand these things, because when they think of neurotechnology, they think of all the gadgets you have to put on your head, and they look kind of scary and dangerous, and they're not going to do that. But they have to be educated that this can help. That's part of the expense of doing this. There is the expense of educating the public on its health, on brain health, and how this is actually going to give them an advantage. The adoption of brain monitors also requires shareholders get invested and understand it. I'm not going to mention one of the venture groups that I worked with, but their sponsor here, And years ago, 2 years ago, I was talking with them, and they just said, you can't do what you're doing. It's not possible. Even though it's been vetted by Samsung, Jaguar Land Rover, Panasonic, and the bioscience divisions of several automakers, they're going, can't do it. So I was like, okay. But they have to take on the adoption of the technology. You also need, we need options that are make sense to people, that will help, right? Things that are easy to use. So I don't know the level of the audience and where you are as far as neuromonitors are concerned. So if you know all of this, just hang with me. I'm going to go through this quickly so that you kind of understand how neuromonitors kind of work. So the brain is just comprised of billions of cells, and the ones that we are particularly interested in neuromonitoring are the ones on the surface. They're pyramidal cells. They're lined up, and when you actually are in a cognitive state of some sort, or you're paying attention, very focused meditator, something like that, the cells, not one single one just fires, but the signal that we pick up is the aggregate of hundreds of thousands, if not millions of these cells firing at one time. And it has to push through various media, right? So you have the cerebrospinal fluid, the meninges, the skull, then it pushes or pulls on sensors on the top of the head, and you have EEG, which is a very sophisticated voltmeter. And then you can do experiments and see what your brainwaves look like and that kind of thing. So they're very, very small. They make that energy through firing neurotransmitters, and that tiny bit of energy has to be always summed up for us to get it. It's kind of a volume conduction that occurs. So it's most likely pyramidal neurons, hundreds of millions, if not thousands. Again, there's a depiction of the media that it has to travel through, so it's really relatively corrupt by the time we get it on the surface of the skull. Anyway, so the various waves, if there is a wave that is dominant, if you're dominant in delta, you're asleep. If you are a dominant in delta and you have alpha spindles in the delta, you're in REM sleep. We all know this from years and years of working with this. If you have high theta as the dominant, you're daydreaming or in the twilight of sleep. If you have high alpha, you're relaxed, alert, and awake. So we basically know what these wavelengths look like, and they're all separated in hertz in different bandwidths. So it's pretty simple. The types of monitoring we use with this type of device, this kind of very passive device, it does not at all emit anything into the user, okay? So when we're using this, nothing is injected into me, which is really important because people are afraid of the radiation coming from their phones and other things, but nothing. So think of this as a large microphone that just listens to the head of the person that's sitting in front of it. And that is a passive monitoring. Now, it becomes active monitoring or reactive monitoring when something goes wrong in the car. So if they're drowsy to a point where it's dangerous in driving, then the car, most of the auto manufacturers have decided that we're going to shake the seat, and we'll put a little audio warning on. Some car makers want to waft coffee scent into the air of the car so it stimulates you a little bit. But then it's going to escalate. If you don't do anything, you go, I'm fine, and you keep going, then it escalates. Then you're going to have the auditory and the visual warning and haptics going off until we try to persuade you to get off the road. By the way, active monitoring down is the training module. That's where we actually use it for training. So I've worked in the field of training everyone from NASA pilots to Olympic athletes. We've worked with Olympic bobsled and luge for years. I trained Da Vinci robotic surgeons at 3 medical schools. So the technology is used in active monitoring, and that's a whole other story in itself. So these are the 3 types that we typically are using here. The current view of the field is Emotive has beautiful design. Muse is upstairs. They have a beautiful design. NeuroSky has a beautiful design. The problem is that you don't see anybody driving their car around wearing one of these, right? You don't really see anyone unless they're at home or maybe up in the booth, because we're all a little bit nervous about putting these things on our head. So Freer Logic has developed the headrest module, and we also have a body-based application. We'll be coming out with the body wave wristband, I hope, this year. We have the armband already, but we'll have the wristband this year as well, I hope. So what are the benefits? The benefits are that we've got increased attention. We can do meditation. Hopefully I'm going to get one of these meditators to come up here and use this today while we're here. Relaxation, cognitive load, peak performance, drowsiness, emotion, sleep, distraction. And everyone familiar with the term IoT? If you're not familiar with it, it means Internet of Things. When you get connected to the Internet of Things, that means your brain is going to be connected to your phone. What it would be like to pick up your phone and start to control the apps on it by mind alone, right? Which controls maybe your refrigerator at home or your garage door at home. And it sounds silly, but we're working on doing that right now. And also brain fitness, which is something we're very, very interested in. So this is a very, very interesting statistic. The demand for brain fitness applications is growing by an annual growth rate of 51.2%. All right? That is substantial. That is billion-dollar industry. That is several billion-dollar industry. Last thing I want to leave you with before we actually demo is we have labels on everything we eat, yet the content we consume has nothing on it. And the reason that goldfish is up there, I don't know if any of you are familiar with a study that Microsoft did in Canada, but they took poor old Canadians and tried to assess how long their attention span was. Turns out they have a 7-second attention span. And that goldfish up there, he's got 9 seconds. So what does that mean? Well, if you could see the statistics, the use of our cell phones and tablets closely correlates to the decline of our attention spans. So everything we consume electronically affects the way our brains function. So where does this fit in with neuromonitors? Neuromonitors are not a preventative, but they help you achieve what you have not been able or what you have lost, right? We recover what capacity we have had for attention, for peak performance through the neuromonitors when used for training. Make sense? Okay, let's play. Can we switch over to the app down? Yeah, I think that's the first one. No, second one. Thank you. Let's connect. Well, don't connect yet. Can you disconnect? Well, that's okay. Jeff, is Ahmed here? No. Ahmed in the house? No. Jeff, you want to be the victim today? You know, Nicole hasn't come up. You think you were going to come by? All right. So if you would sit here, the electroshock component is not yet built, so you'll be comfy.
Should I take my vibrators out my pocket?
Yeah, you could just leave those over there. I had no idea if they'll do anything, but let's just sit there. So yeah, you can sit right here, and yeah, had a little bit to drink already. Okay, here we go. You look so nervous. All right, so you're going to have to be able to see the screen, so you can actually turn your back to the audience. Or yeah, you can see that. Can you see that down there? Can you scoot up? Perfect. Can you hit a retry for me on that? We may have to do it 2 or 3 times because there's so much Bluetooth in the room. And you don't have to touch. Don't touch the headrest. Just sit forward. Okay, there you go. So once this, you can start to see that we're picking up her brain data right now. And that's coming from about a foot away. Pretty sexy brainwaves you got there. All right. Everybody kind of likes that. So watch what happens. Can you take your own hand and insert it between your head and the headrest? Just wave it behind your head. So she's going to disrupt this field. Okay, let's stop doing that now, and let's let it recover. If I do it, people go, Freer's got a switch in his hand. I got stopped by a neuroscientist at CES, unlike Jeff. And he goes, let me see the switches. I said, what switches? He goes, let me see your hands. I said, there are no switches. All right, so the brain data that we collect here just correlate to what I told you earlier and the different brain states. So now let's actually, can we hit disconnect, please? Lower right corner. Perfect, thank you. Okay, so let's just minimize this and go on to the where we can play. Can you maximize the screen for us? That would be a no. There, up top, there you go. Thank you. Super. Okay, let's hit connect. We may have to do this a couple of times too because of all the Bluetooth in the room. I'm certain we will. All right, so now it says that we are connected and we see this green bar. And this is indicative of your attention. So the more you pay attention, the higher you can raise the green bar. So if you would, try to focus. And now you're laughing and cheering for, distracted a little bit. So does my voice. So let's be really quiet. And if you would, do your best to push it up. Perfect. So if she stays above 25%, it's going to allow her to drive. So we're going to increase her cognitive load. Can you start the video for me here? Just by clicking the blue button. Thank you.
Driver distraction detected.
All right. Now, she's
Driver distraction detected.
Oh, let's try that again. Now she is brilliant. Travel. All right. Do you have your cell phone? No? All right. How about if I loan you mine? Where is my cell phone? Oh, that's enough to
Driver
distract her.
distraction detected.
All right. So there's your cell phone.
Pay attention
You can
to
see
resume
just having
driving.
it and trying to open it and what it does. Now, let's go ahead and do both. Can you text and...
Driver distraction
No.
detected.
Okay, so let's stop. And let's just go back to full
Pay
focus on
attention
this.
to resume driving.
I'm kind of worried.
Pay attention to resume driving. Pay attention
right.
to resume driving.
Can you stop the application for me? Hit play. Stop the player. You can just close it. That's good. That'll do it. Okay. So much. I know that made you nervous coming up. You did great, though. All right. So what you just saw is that this thing, from about 8 inches away from the back of her head, is accessing her brain data in real time and then allowing us to throw an algorithm over it and look at a simple attention function in real time. Now, I told you that we already have mastered the drowsiness application. We've reversed the drowsiness application, so we have a sleepy series that we're going to put out shortly for people who have trouble going to sleep. So we reversed it so that it like my lecture is doing to you right now, it's going to make you drowsy. All right. I've used it and I've fallen asleep 4 or 5 times just trying to edit the material as we're doing it. So it's very, very functional. But you can see all the applications with neurotechnology. If I wanted to use it to get in a peak performance state, as I did before I came down here, so I'm not nervous standing in front of you and that I can talk to you as a normal person, my hands don't shake. It's because I can use technology to help me do that before. And I used to be a professional fighter. And so I would actually do that before I would fight. And and it's the cage, that stuff, anybody watch the crazy stuff in the cage, UFC, that kind of thing? Probably we're an elevated audience, we don't watch that stuff. All right. Unfortunately, I did that, and this is one of the tools that I use to get ahead in that game. But I thank everyone. I think, by the way, I've told these guys personally, but I want to say it in front of everyone. The vibe here is just incredible. The people are incredible. What they have put together is incredible, and I just want to make certain, I'm certain they hear it all the time. But I just want to bring it out in the open. I'm thrilled. I go to a bunch of these. This is probably one of the best ones I've gone to, just in the people they have and what they've given us and offered up. So I thank you guys. Thank you.